Cohabitation of niche habitats, especially where such habitats are limited, enables greater species diversity and may be an important mechanism of species richness in high biodiversity environments. This mechanism is investigated by Camp et al. By studying clownfish cohabitation in the Coral Triangle, an area which covers only 3% of the tropical Indo-West and Central Pacific, but contains 52% of its total reef fish species, as seen in this figure. Grey areas of disks indicate proportion of inter-specific cohabitation in the area, specifically concentrated around Hoga Island. Clownfish are an ideal model group. Being obligate commensals, they cannot persist in nature without host anemones. Previous scientific consensus was that clownfish competitively exclude other species from hosts. However, the authors document that around Hoga Island, clownfish coexist in interspecific groups, and that cohabiting species are often phylogenetically unrelated and morphologically different. This study systematically tested a hierarchy of hypotheses to explore what factors facilitate interspecific cohabitation. The central finding is that clownfish cohabitation only occurs in areas where the number of clownfish species exceeds the number of host anemone species, and that this is facilitated by a fine-scale spatial separation of the host anemone, as illustrated in this figure. This mechanism allows both cohabitating species to share a common habitat, with a designated subordinate species occupying the peripheral areas of the anemone. The diagram shows how these spatial divisions alter according to the cohabitating species. It was found that space used per fish was decreased by 50%. However, aggression did not increase, as shown in this graph, comparing the aggressive behavior of the most and least aggressive clownfish species in both intra- and interspecific cohabiting situations. This graph shows that when a species cohabits intra-specifically, aggression is displayed on average 14% of the time, compared to 7% of time in an interspecific situation, taking into account aggression both within and between species in this situation. Therefore, despite reduced space, dominant species appear accepting of subordinate species. It is suggested by the authors that this is because the dominant species mutually benefits from the enhanced growth and protection of the anemone that cohabitation allows. This very interesting paper highlights the importance of habitats of high species richness, such as is found in the Coral Triangle, and thus the importance to biodiversity of conserving such environments.